Okay, the main question is, how can we calculate probabilities if our values of interest, our particular data points, are not exactly 1, 2, or 3 standard deviations from the mean? If they are exactly 1, 2, or 3 standard deviations, of course we can use our empirical rule, the 68, 95, 99, 7 rule, to help us out. But there are going to be plenty of situations where that's not the case, right? Not everything is going to fit in that nice little box. So let's say that we wanted to investigate that further. Well, we have now some tools in Excel to be able to help us do that. I'm going to do some more examples of those along with some visuals just to make sure we're tracking everything correctly here. So we're going to use Mr. G's AP statistics course again, where the mean scores, again, that's mu is 75, and the standard deviation, again, that is sigma, is 5. And so we're going to say, what's the probability a student scores between 72 and 78? Well, 75 is right in the middle. If we have a standard deviation of 5, that means we go up to 80. So notice we skipped right over 78, which would be somewhere in here. And then if we go backwards, we go back to 70, and we notice we skip over 72, which would probably be about there. So we're looking for that area. Again, we can't use the 68, 95, 99, 7 rule. So we're going to instead bring up our norm dist. So this one, again, we always do equals norm, and even when you start typing it right, you're gonna get a list of things. So we want the very first one, and you can just hit tab, it'll fill it in, or you can type in the whole thing. So norm dist, and it tells us what we want. I just reminded us up at the top just so we kind of kept an eye on things. And X is saying, what is your specific data point? What's your data point of interest? Well, okay, if we're looking between two values, well, maybe first I need to think about, what's maybe the lower value? So if I just put in 72 here, we've got a mean of 75, standard deviation of 5, and let's say, yes, true, I do want it to be cumulative. Remember, we only use false if we're talking about a single value. So in general, we're going to be using true, although we will see an example here where we use false. But for this one, we're using true. And so this is for 72. And so we get 0.27425. Now, if we go back to our document, let's think about what we just found. What we just found was all of the area below 72. So we actually found all of this stuff. Right, and this is, again, this is 72 right there, and our 78 was up there. So we can say, well, I found all of this area, so basically the area to the left of here. How can I find just the blue shaded part? Well, what if I go to 78? I do the same thing, then that's going to give me everything to the left of 78. So let's go back over and say, okay, I can do, again, norm dist, and then our data point now is 78. The mean still 75, standard deviation still 5, and we still want a cumulative value here. So this is everything to the left or below a score of 78. So we've got below 72, we've got below 78, and now if we want between 72 and 78, then we can just take the difference of those two, right? If we subtract those two, we're basically cutting off all of the extra stuff that we don't want below 72. So we can just do equals the entire below 78 value minus the entire below 72 value. Okay, so we get this 0.45149. Another way to do that, you could do that in one fell swoop here. So, sorry, norm. So we could say, well, let me take the 78 value, everything to the left of 78 or under 78, right? That would be this. And I could just do minus and then do it again, right? Do another one of these and then take away the part that's below 72. Of course, we're going to get the same value. So if you want to see it in multiple steps, that's fine. If you want to do it in one fell swoop, that is also fine. So we end up getting 0.451. Let's say we just want to go to 3 decimal places. And in general, that's probably going to be enough. Right, of course, we know that we could write this as a percentage, 45.1%. But, you know, Excel is going to give this to us as a decimal, so we might as well just kind of leave it that way. Okay, so in part B, what's the probability of student scores between 83 and 89? Okay, well, once I've set this up one time, right, I could go through these 3 steps again, or I could just say, all right, well, let me do everything to the left of 89 and then take off the stuff to the left of 83. So I'm just updating my X values here, my observations or my data points. So 89, this one's going to be everything to the left of 89. This one will be everything to the left of 83. So we get 0.05224. Again, if we're just doing decimal, we'll say, or sorry, 3 decimal places, 0.052, right? But however many decimal places we need is fine. Again, remember that norm.hist is always going to be, or sorry, I keep saying histogram, norm.dist, distribution, is always going to be to the left of the score as long as we say true for cumulative. Okay, sometimes we have questions like this. What's the probability of student scores at least 73? So it's going to be the other direction. Now, we said our mean is 75. Standard deviation is 5, so 70 is back there. So 73 is like here somewhere. And if we're saying at least, that means we want all this area. Well, we know that our norm distribution is going to give us the area to the left. So we can just do 100% minus the area that's found there. Or again, because we're doing decimals, we can just do 1 minus that area. So we want a score of at least 73. Well, okay. We can look at below 73 and then above 73. All right, so below 73 is going to give us, sorry, I keep doing that, norm.dist. Okay, I'll get it down here. So if we said below 73, we'd say 73 is our data point, 75 and 5 are the mean and standard deviation, and then let's say true. So we get this much is below 73. So above 73, we can say equals 1 minus that amount, right? And those two together should equal 1 or 100%, right? Because if we choose a point to split the data, then whatever percent is below, the remaining stuff is above. So we get this. So 0.655, I will say. And it should line up with our answer. So if we get 0.655 and we look at our visual, right, half of the data would be above 75, and we see we've got a little extra amount shaded. So we should definitely have an answer greater than 0.5. Sure enough, we do. So if we forgot to do the 1 minus part of this, and we got our value here, the regular value for norm dist, that was 0.34458, we'd say, hey, wait a minute, that doesn't seem right? I've got more than half of this shaded. So sometimes it can be helpful to have these visuals. That's why I've been kind of saying, hey, this is helpful for yourself here. Okay, what's the probability of student scores less than 89? Okay, well, this one's actually not too bad because we just say to ourselves, all right, 75, 80, 85, 90. So 89 is going to be over here somewhere. So less than that is going to be most of the data. So we should get an answer that's pretty big, right? Pretty close to 1. And in fact, since it's shading below, we can just say, okay, cool. I want something below 89. So I guess all I need to do is update my little formula here and say, okay, 89 is my data point. And we get 0.99744, right? Most of the data. We're almost 3 standard deviations above the mean there. So 0.997, we'll say if we're rounding to 3 decimal places. Okay, if 150 students took the test, approximately how many, so not what percent, how many scored less than 89? Well, okay, we already have the percentage, right, or the proportion of students who scored less than 89. So now we just need to multiply by 150. So if we ask ourselves, well, how many? We just take the answer that we got here, and I would say use the unrounded answer, right? Use the most exact thing you can. Multiply by 150. So basically 99.744% of students, so 99.744% of that 150, and we get 149.617. Okay, so this is basically all of the students, right? If I round to the nearest student, that would be 150. So we would say all of them. right? So basically we think, right, all of them. Of course, that's not always going to be the case, and certainly because these normal distributions are always approximate when we're talking about real data, discrete data, then it could be the case that one or two or even three students scored up here. It would just be that they are probably outliers for the data, right? The majority of the data followed the normal curve, and then we had a couple that just lied outside of that. All right, and then lastly, what's the probability a student scores exactly 89? So this one I wanted to make sure to include because we have been using true for all of these. So this is a situation we're going to use false, and I'm actually just going to copy this guy down because this one used right below 89. So we have 89, 75, 5. All that is going to stay the same, but I'm just going to change this to false, and it's going to tell us, okay, how many people do we think scored exactly 89? This is a very, very low number, so this we think that right, basically almost nobody did, right? 0.00158, so 0.158%. So if I go back over here, what's the probability? If we're rounding to 3 decimal places again, is 0.002, right? 158. The 5 would make us round up to 2. Which makes sense because we didn't really have anybody that we thought scored above an 89 there. We could choose another number, right, if we just needed to see, like, how about exactly, let's choose something closer to the mean. So how many people scored exactly, let's say 76. I just change this guy to 76 and we'll see what percent. All right, so we think about 7.8% of students scored exactly 76. Right, and then we can do the same thing. If we want to know how many, just multiply that by 150. So same tools, we're just kind of toying around with them. But anyway, that's just giving us some flexibility, looking above, below, between two values, and at exactly one value